Yeah, so I actually started Assembl last March, which was around the same time that Stephen Hawking died. And I was thinking before that for quite some time about the problems in science, because I have sort of a history with science. I spent a lot of time in different research programs, and I have a lot of friends who are involved deeply in the scientific realm. And they were reporting problems in their labs that I really wasn't that aware of. And I realized that the public probably wasn't so aware of that either. And the problem that I identified then was that a lot of collaboration was not really collaboration, it was competition. And that was because there was no incentive to work together, and there was always an incentive to compete. And the problem is that this persists in modern day science. So there are solutions right now that are working on solving the publishing problem, that are working on solving the problem of data analysis in science. And there's amazing stuff happening in science. Science is really one of the freshest and most interesting disciplines of the world right now. But it could be so much more progressive, and it could be so much more useful if we were able to work together in this sort of union of networks. And I started thinking about how that would be possible. Of course, this was the time that the tokenomics had taken off in the end of 2017, and we're still continuing through 2018. And I started thinking of how I could build token models in order to incentivize researchers to collaborate, in order to pool their knowledge in one study, and then be able to work with one another in that same study and actually get rewards for collaborating and essentially be disincentivizing competition. But I soon realized that there are some problems with the token model, because a lot of the token model is based on the assumption that people can actually use them in practice. So human-centered software was what I started thinking about. And I morphed this more into a vision of how you could build tools that appeared really simple. In other words, tools that people could use as tools. In other words, use as they would like to use, instead of over-architecting. I didn't want to impose anything on the end user, but that would still be useful. And I think that's really an art. I think a lot of the great design and a lot of the great software and technology that has come about because it is focused on the person behind it and not on the software itself. And so I started thinking about how you could build solutions that weren't over-architected and weren't too complex to use, but still were usable for a certain application. And then I started thinking about data, because I had a friend who was working in AI and machine learning at Google. And he was telling me about many of the new enterprising things they're doing with machine learning, artificial intelligence at Google, and exactly how that relates to the lower level aspects of data. And actually, they were looking for data to train their AI on. And I started thinking, wait, I know about science. In fact, I have this history now. I've been working on this project. And one of the things that everyone generates in science is data. There's no scientific field where data isn't generated. That's the one constant. And I started realizing if this data were shareable and if it were usable by anyone, it would be an amazing system. And so I started working really hard on exactly how to build the system and exactly how to incentivize people to use it. And then I looked at parallels that we have in our modern world. And one of the most exciting ones was open source code. And so if we look at open source code, like platforms like GitHub, and we have open source licenses like the MIT license, the GPL license, BSD license, etc. The reason that open source code flourished was because there was a framework for it. And I started realizing what you need to make something like science flourish is a proper framework. That's where the idea for Assembl came from, is a framework for science and a framework for data within science. And the first step to starting on that was to make data shareable and to make data essentially usable between silos, between boundaries, all of this. And then you get into some of the interesting practical problems in scientific data, like the fact that right now, it's kind of unbelievable, about 72% of scientists still use CDs, DVDs, hard drives, and removable thumb drives to share their scientific data. And the reason for this is that much of this data is very large, and in order to share it in a government-compliant manner, and quickly, and with the colleagues that you want to receive it, you have to store it on physical mediums to know who has access to what. But one of the most amazing things about blockchain technology is that we can permission things, and we can now know who has access to what data, and where data is being sent, and make that data sending process fast and efficient and very secure, as well as, in the process, government compliant. So really addressing this problem at its core was what we started to work on. And after a lot of work going through many researchers, talking to many scientists, friends of mine, I molded this vision into a more concrete form of exactly what we could build. And that's how I came to where we are today. Through many meetings with researchers at universities across Europe, some in the US, I've really honed this vision down into what we really need. And that is a decentralized data exchange platform. Because data is at the core of science. And we need a way to incentivize this data sharing. The best way to incentivize this data sharing is by licensing. Copy the models that already work. There's no need for a token model or for some complex model that requires access to private keys, etc. in order to achieve something like this. And we focus on the simplest thing possible, licensing, just like GitHub did it, just like there is an open track record with open source code. And we're modeling that for the open science movement. Now, our first app, which we're going to deploy quite soon, is Assembl Triton. And that is our core data transfer app. That allows scientists to transfer data between one another in a secure and decentralized manner with proof of who they're transferring the data to, and then be assured that the scientist on the receiving end has gotten their data and is knowing that the data is licensed in such a way that they can only use it for specific purposes. And this is the same way that open source licensing works, but we can expand this to an even broader field of licensing. And by that we can say to scientists, if you would like to share your data and get credit as an author in the final publication, do so. And if you would like to share your data and get credit as maybe simply a contributor, do so. Or if you would like to sell your data and you don't need credit, you can do so as well. And this way we build a flexible model for scientists that is built on their own terms. It's not on our terms. And they can decide exactly what they want to do with their data and exactly what they want the scientists who receive their data to do with their data. And then on an even broader point, we can branch out to other fields which relate to data, like AI and machine learning labs, institutions, private science institutions, and provide high-quality scientific data to the places that need it most. We have tons of data, but what we need is high-quality data, and science is the best place to get it. Now, that's really the story of how Assembl started and how we kind of got to where we are, and I would love to hear the next question. I actually graduated high school very early. In fact, I sort of dropped out. Now, I still technically have a diploma and I graduated, but when I was in high school, I was also spending time at the US science fairs. And so I went through the California Science Fair, the US National Science Fair, or the equivalent to the US National Science Fair. And I gathered many awards. I gathered a total of about $15,000 in prize money for the development of an app that allowed anyone to input complex data into a mathematical computation engine and receive results on the other end. So in other words, abstracting away the complexities of equations, etc., and bringing that to a very simple solution where you could simply enter basic data and you would get basic results. And now that was a fascinating tangent for me, and I had a lot of fun and excitement in working in science and meeting other scientists and meeting people who were active in this realm of innovation and entrepreneurship and all of that. And high school became a very stale thing for me, and so I started working as hard as I possibly could to get out of there. I would consider that somewhat of a failure because I didn't put in the work that I could have. I sort of was cowardly. I ran away from it because it wasn't something that I wanted to do. But at the same time, I realized that failures can also be important moments. And I don't think I would have gotten to where I am today and the potential impact that I can have with Assembl had I not gone through the failure of realizing that I was not in the right place. And I worked my way out of there. Now, on the Assembl side, we've had some interesting failures as well. I guess the most important one was the one where I had been working for 3 to 4 months on building a complex model, a complex architecture of tokenomics, of incentive mechanisms, and even on a broader scale, sort of an architecture for everyone in science. So not just publishing or not just funding, but everything. Data, funding, publishing, even more niche topics like connecting to citizen science networks. And at a certain point I realized I was doing it wrong because this would never work. It was too big of a project and I had worldwide ambitions. I wanted this to be global. I wanted this to change things truly. And I had spent a lot of work on it, really 12 hours a day, every day, for 4 months. And at the end of it, I came out and I realized I've been doing it all wrong. What I need to do is go to the people who need my help. I need to make software that's by researchers, for researchers. I need to get their input. And I don't need to be the one who thinks that I can architect a perfect system, because I can't. It's up to the people who are going to use it to build it. And that's really become my ethos with Assembl. That's the main thing that I learned. If you want to build something for people, you have to get their input, because you don't know what they need, and most of all, you don't know what they want. And that's really what has brought me to the place I am today, in terms of building the simplest and most human-friendly software that I can. I've thought a lot about this, actually. I've thought a lot about how Assembl could be the biggest paradigm shift in science ever, potentially. If we have a way that scientists can collaborate worldwide, that anyone perhaps even can contribute to scientific studies, we really change the way that the world works, because we make it an inclusive system where everyone has access and everyone is a contributor. And that means that everyone has skin in the game and everyone has a vested stake. And so I believe that for really large-scale problems that we're facing today, like climate change, like even social problems, or even deforestation, anything that relates to large global-scale problems, there is a solution. And I believe that solution lies mostly in the individual, because the individual is an extremely powerful thing. The individual person is an extremely powerful force. And so it's important that we give everyone the ability to feel empowered, and to feel that they are very important, that everything they do matters deeply, and that's because it does. Now, I have the vision that if everyone were contributing to science and saw the results and saw what they were putting in, and realized that the system was transparent and not a top-down, elitist, exclusive system that was trying to con them into believing one or another thing for political aims, we could really change the way that the world works at a fundamental level. And that means that every person would know that the world that they were living in was created by them, and not by someone at the top. And the way that we can do that is by building a citizen science network, where if scientists want data, if they need data on certain topics, like climatological data, let's say data on the entire western seaboard of the United States, edge cases like this, but even larger scale studies where you want to collect data from a worldwide perspective, having the ability to do this, having the ability for individuals to send data to a central point and receive a payment or receive some allocation for doing so, would be an amazing system. And we know how we will build this, because the relatively simple technologies that lie at the core of it are already developed. And all we need to do is build the right marketing and build the right, essentially, image on top of that. And that is an image where everyone has access and everyone has freedom within this greater system. Now, in terms of our real pragmatic goals, we're looking at a few plans of expansion. So right now, our main product is really a pragmatic solution. It's an alternative to current solutions like cloud storage or even decentralized data transfer apps that exist today, because it's an improvement. It's cheaper, it's easier to use, and it's faster. And it's more secure in many cases. And so we really build that as an alternative to stuff like Dropbox, Google Drive, even email or FTP, SSH, whatever it may be. And that's our main sales pitch right now. Just make it easier for you to send data between you and your colleagues. That's going to be our plan for the next year and a half approximately. And within that time, we're going to work on developing the libraries and necessary underlying technologies to have a more contributive network, where anyone can upload data and download data in a federated system. What federated systems are is essentially you maintain control over your own data. It's still your sovereign data, but you can share this data with anyone else. So it's almost like a cell wall. It's porous, and it has essentially the ability to transmit fluids, or let's say in this case, data, outside and between these walls, but these walls are still established. And so you still have a clear example of what your data is and isn't, and that you can see where your data is going and where it isn't. Now, we plan to build this into the EU Open Science Directive and expand this to universities across Europe and hopefully across the world within the next 3 years. And as we build that up, we hope to work more on building a citizen science system where anyone can receive micropayments in order for contributing data to larger studies where scientists request larger data stores. And we have a practical example of this, which is there was a study recently that attempted to collect data on the entire western seaboard of the United States. But doing this with the 3 researchers they had was nearly impossible. And that's because to collect data in a reasonable time frame where the data would be all similar and equivalent would be impossible. It would basically take 24 hours of work a day for 5 days per person to track 1/3 of the seaboard each. However, if you had a system where you could go and dispatch a request to every person at their local station, or even just to every amateur scientist at their local station, and get them to collect this data, and then send it in, and receive some payment for that on a quality vetted basis, we could really build this contributive network that I was talking about before. And that's really our 5-year plan, and that's where we're going in the next 5 years. Beyond that, we have many ideas, and we have many solutions that we're thinking of building, but again, we don't want to over-architect anything. This is all about simplicity first. The CV Labs incubation program has really been sort of a tremendous chapter in my life. This has been maybe the longest 10 weeks I've ever experienced, but also the shortest. So it's gone extremely quickly, but when I look back, I've experienced so much, and I've learned so much, and I've matured my company and myself so much. It's almost unbelievable to think of how I went into this program. Now, the best thing about CV Labs is that it's sort of a holistic ecosystem. So everyone is contributing. Everyone is with one another, and everyone is friendly. Everyone wants the best for everyone else. This is very different from a lot of other ecosystems that I've been in. For example, in Silicon Valley, it's also a similar effect, but I haven't felt it in the same sort of family type way that we have at the CV Labs here. And that's really been the main factor that has made me love this place. I really do love this place. And Tsu is a wonderful city. The life is really great. The lake is amazing. The weather is nice. The nature is beautiful. And to have that escape from work, to have that opportunity to distance myself and take time to ponder and think about exactly what I'm doing and how I can continue and how I can mold this into something that will really change the world has been very, very useful. So all in all, the CV Labs program, the CV incubation program, has really been a holistic sort of transformation process. We came in here, obviously with an idea, with code, but it was all scattered. And in this process, we've been tempered like a sword, and we've been turned into a very lean company. We have an idea of where we're going, actually a very clear idea of where we're going. We know how to get there, and we know what we need to do in order to get there. And that's what CV Labs has done for us. I really also love the people who run the program. For example, Pavel, Olaf, Pascal, of course, Jakob, our wonderful videographer, who is taking this video of me right now. And it's really great people who are here. Now, if I were to give some slightly critical feedback, the main thing that I think could be improved is to build a system that's a little bit more, how would I say that, demanding of the students, or the incubatees, well, we feel like students. But in the first 2 weeks, we really had this. So it was a program where we were essentially stop and go the whole day, and we always had something to do and always had something to work on. Of course, it's important to have breaks in between to work on our companies and to develop code. So what I think would be actually a really good system is if we had 1 week, intro week. That's the boot camp period. Quick, you get everything done, you sleep very little, and then you're over with it. You meet everyone, you're done. Then you have a week to relax and code and build everything up, and you get instructions on what you need for week 2. Then week 2 comes in, and that's the second boot camp week. That's where you really flesh everything out, and at the end of that is the pitch day. And then you have a series of successive weeks, on and off, where each week that is off has some programming or content, but it's not required necessarily or mandatory. And then the weeks that are on are intensive, and they have people who really want you to do a certain thing for them, and not just presentations, but really interactive workshops. Of course, I know that's really hard to do, and so I would say that overall this has been a really amazing program. It was much more put together than I thought it would be, if I'm quite honest. And it's really actually been a much more important experience than I thought it would be. I kind of pictured this, I would come to Zug, I would work in the co-working space like I had before, and I would just continue there. And maybe we'd get some more stuff done. But it's really been like an accelerator. It's been an incubator. And we've gone in like weak, babies, and we've come out like half-matured adults. And that's a really important thing. That's a really good question. I like that question a lot. I have a lot of idols in science and a lot of people I really look up to. It's a hard question to answer because it's a bit unbounded, and there's so many scientists who have such an established lineage that I would love to receive advice from. But I've always been a little bit of an unorthodox person myself. I don't necessarily follow the chosen path, and I've seen a few people who fit with that, both in modern times and ancient times, or, well, at least a while ago. So if I were to pick someone who is no longer on this planet, I would probably pick either Nikola Tesla or Carl Sagan. Now, Tesla was a fascinating person because he was incredibly smart, but he was also sort of plagued by his own genius. And that meant that he was alienated from the rest of the world. And I've experienced that myself, too. It can be an alienating thing to feel that you have ideas that don't fit in with the hegemonical society that you live in. And I really admire Tesla for that. I really would have loved to get Tesla's input on how he worked with that in his own life and how he managed to live with it. As well as, of course, on a more scientific perspective, exactly what he thought about the concept of essentially a global network for citizen science or for data science, because he had very global ambitions as well. With his Tesla coils, etc., he had this vision of anyone having access to electricity worldwide, anywhere, that everything was vibration, everything was connected in some way, and he was right. We know that he was right. Everything really is connected in some way. And I'm a true believer in that as well. So if we can just foster those connections a bit better, I think we can improve the whole world drastically. On a more modern note, there's a fascinating mycologist named Paul Stamets. So a mycologist is someone who studies fungi, or fungi, which are mushrooms. And these mushrooms are essentially the underpinnings of all our soil and of most of our plant life, and even perhaps our life. These nets of mycelium, and even more fringe topics like psychedelics, mushrooms, and the healing powers of things like lion's mane mushrooms and other mushrooms that have been explored throughout history. Because fungi, I'm mispronouncing this every time, sorry Paul, are amazing creatures and amazing organisms. So I would really like to get Paul's input on exactly how he has dealt with perhaps being alienated in science, even though he's an extremely well-known and popular scientist. And I would also like to get his input on how we could work with him or with anyone else to build this network. And again, there are those parallels with a global network, because mycelium is actually a fascinating thing, and it underpins most of our soil, and is actually a communicative network. And as far as we know, has some intelligence. And so these fungal networks actually communicate with one another, and they relay messages from trees back and forth across vast distances in the US and Europe and the rest of the world. And I see the same thing in what we're doing. Thank you.